Hello, can you hear me?
Yes.
Okay, let's wait for a couple of minutes. Hello, I think we can start now. Look at the message. So today's topic then, Jimmy, you are going to talk about repository, right? Today's meeting.
Hello?
Hello, yes,
Hey, Johnny. Hey,
where are we?
hey. Are we waiting for someone or can we?
I
Should we
think we
start?
can start.
Okay.
So Jim is still are you here? So you're going to talk discuss this repository today. I think you sent something in the past week. Also, you have message system. Jim, I
James,
think
yeah.
I think it's muted.
Is Wei Tang?
No, I think we are reading for Jimmy because I'm not sure he's here.
He's here, right?
Jimmy. Oh, Jimmy from Molex.
Yeah, that's right.
Yeah.
Okay. I'm not seeing him in the attendance list. Let me see if I can ping him.
Yeah, that's
Yeah. Let me try to ping Jimmy. And in the meantime, maybe. Yeah, he may not be on Teams, but we have a channel. We have a channel with Molex, and I will try to see if I can reach him there. Last time I remember there was a lot of discussions and also good feedback on the contribution, right? So the contribution so far I think is very good, and we are
Mhm.
just discussing about the way how we can make it compatible to fit in the SONiC framework, right? So there's some concerns on how we can merge it back to the master repo, but the contribution itself, I think it's very good.
Okay.
Yeah, we think cannot.
So
Yeah,
can you
okay, you're
guys
here.
see?
Okay.
Okay, I'm here.
Ah.
Yeah, right.
Okay, cool.
Okay.
Yeah.
Okay, thank you. So I think Ali and SLink team, they shared all the repos except build the image, right? So at this
Yeah.
point, probably we can go back to review this implementation design proposal to sort of prepare for merge up to the official master, like try initiate this activity, right? It will not be easy, but we probably can. We needed to start. So this is the main goal of the feedback. So today I like to talk about the two repos. One is the platform common and also the platform daemon. We have looked at them and we like to have some feedback on that. So before that, I tried to kind of communicate to the team that the goal of our project and how at the end, how does the optical device vendors, right, or the users can benefit from our project, right? So overall, let's have an agreement and on the consensus on how do we are going to use the SONiC OTN. So to start with that, let's look at how it works now, right, for the switch and the routers. So the SONiC build image is the parent repository for everything. All the other repository is a sub-module of SONiC build image. So it is a very good kind of a structured. So after you clone SONiC build image, you do a make init. So it will initialize the development environment, like all the containers and everything. Then the second step is really, it is a generic build framework. So you need to tell the SONiC what the platform you try to build, right? So now the platform, the terminology here, the platform is a really ASIC vendors, right? So this platform is not the other platform we are going to talk about. So here the SONiC use the platform as the ASIC kind of a vendor. So for example, you can say Marvell, you can say Broadcom, right? So which means like I want to build a SONiC image, which is running Marvell chip or Broadcom chip, or there's another one called the VS, virtual chip. I think we looked at this last time, right? So that is sort of the second step. Then the third step, it will just make a target image. SONiC, like say this XX is exactly the same as when you type in the platform, then there will be an image come out, right? So this image now is okay. So now we have a platform, right? Now then also a concept of a device. Now what is a device? So device is actually the box vendor, right? We said the SONiC is ASIC vendor. Now the device is actually box vendor. For example, Dell, Edge Core, or virtual switch, right? Dell use Broadcom chip to build a Dell box. Edge Core use Marvell chip to build the edge core box, right? And there's a device vendor also included in the SONiC tree, like I say, Juniper. Juniper, they have their own switch. However, they use Broadcom to build switch as well, and they support the SONiC. So pretty much you can load the SONiC image, the SONiC Broadcom.bin onto Juniper's some product of Juniper switch, right? So this is the device. Now, one question is that once you got the SONiC Broadcom bin as an image, right? So this image actually contains all the device drivers from all the vendors, like no matter it's from Dell, Edge Core, and Juniper, Virtual, all these boxes driver is included in that image. Do you see? Because the image is not based on the device, it's based on the platform, which is a ASIC, right? So as long as you use Broadcom ASIC, you can use that image. Now, the ONIE at the installation time, it will find out what is the device type, then pick the drivers, right, for the device. Like because everybody, although use the same Broadcom ASIC, they use different power module, fan, like chassis, line card, all these are different. So the ONIE is the guy to select the device package at the install time, then install on the box. That is our understanding of current how SONiC works. Any question
I
on
have a
that part?
question.
Okay.
So platform is that ASIC level. So being it's provided by this for example Broadcom Marvell or with ASIC vendors. Then this device it's basically a white box. Is that correct?
Yes, exactly. Exactly.
Okay.
So
you just said that this bin also include drivers for a Dell or Edge Core. How could that be? I'm confused because of the bin it's just switch ASIC vendors that they are their platform, and they don't have anything with white box vendors, right?
Exactly. Yeah. That is a very tricky part, right? So they are white box vendors, right? But they use some chip, Broadcom or Marvell, right? So now Dell also has although they use the Broadcom Marvell, but the Dell Edge Core has a different PSU, fan, chassis, right?
Yes.
Thermal, all these are different. So this SONiC bin is actually, it's big. So it will include all the white boxes hardware driver in that bin, which is okay, although it's a big. However, when you install that image onto Dell, for example, white box, then Dell's ONIE will pick only Dell's driver to install on that box. It will not install Edge Core's device driver package onto the box, although it is part of the image, which is yeah. So that is how, yeah. Now, please note that the SYNC-D are all the same. Okay, so we need to understand the SYNC-D, like in the future we call the SYNC-D, OSS, like all these things, they are based on the ASIC level, right? SYNC-D is the ASIC level. Only the fan, power, chassis, the generic hardware, the white box vendor, they have different, right? So that is, yeah. So to emulate that, a current,
Yeah.
like how things work. So we probably want to kind of emulate. So now we want to introduce a new platform, which is optical module or transponder vendor, right? Let's say SONiC platform will be, or now OT is not necessarily, we can just say SONiC and Molex, because these guys, we don't build a switch, ASIC switch anyway. So, but to have a optical transporter in the front, probably it's more clear. That's just my personal kind of thing. So, but the bottom line is every optical module vendor will own a platform, right? Which,
Okay.
yeah, then now theoretically, then when you build the image, then there will be a SONiC SONiC image and Molex SONiC image and the virtual image, KVM image. Okay. So this SONiC image or Molex image actually should support all the boxes which use the SONiC modules. For example, let's say Ali SONiC, SONiC build 5 different boxes for Ali, right? Let's say 1 RU, 2 RU, 5 RU. Now, the module, they are all from SONiC. As long as for that, then this image should cover all the boxes.
So this image is provided by, for example, SONiC, and also not just the optical module, we probably also include these drivers for fans, for PSU, all these things, right? That's what.
Yes, yes. So go ahead.
So because so the build image repo is not coming out. I think it will come out in a week. I think right now the implementation is follow this rule. Yeah, it match. So but
okay.
The name right now we didn't add the OT prefix in the front.
Okay, that's fine.
Yeah.
We can. It's just the idea. Yeah, we can. We don't need.
Yeah, I think we can add this OT in the front of the name, the platform, and I think right now the image you can build SONiC right now, and but the platform the VS right now is not KVM, is VS for now.
Yeah. Last time I noticed that probably we need to create a new KVM platform, not to reuse the VS, because the VS is already used by the switch, virtual switch.
Maybe
right?
we can name it OTVS.
OTV, like a V, whatever. Yeah, we can name that. So let's say at now, because our group, like we have a Molex, we have a SONiC Ali team, and we have a Molex. Then we will together build a virtual one, right? So 3 platform, then 3 images.
If I may interrupt a little bit here, I'm not sure if this is really what an end user wants. Like us and Alibaba, right? So we are kind of in the same position. We all have many different white box vendors. More like SONiC, there could be other vendors, right? So I do not want Microsoft to have to build a Molex image versus vendor A's image versus vendor C's image. You are vendor M, right? So I don't think that's the best solution for us. I just want one optical image maybe for LAN system and one optical image maybe for transponder. So those are quite different, right? So that and then we can the essence of even unifying the OS on hardware is we want to unify them, and so we don't have to run many different OS on different platforms, right? So same here also, like taking an analogy of these routers. Broadcom and Marvell are different switch chip ASIC router vendors. The platform could be just built around them, right? So, but the white box vendors like Dell, EdgeCore, all the other things, SONiC does not build a specific image for Dell. Right? So it's also like Jimmy, you just said, the peripherals, not a core switching chip, the peripherals, all kinds of drivers need to be included. It's also like the Windows operating system or Mac operating system, any popular operating system out there for computing is also, each operating system have many drivers, right? So basically for different peripherals, for different RAM, for different keyboards, different wireless line cards, all kinds of drivers are included in the operating system. But when it comes to core chips, there's only Intel, ARM, different ones, right? So you're gonna build a different OS for those different CPUs, but you don't build a different OS for different keyboards or wireless line cards, right? So that's how operating system is being built. And also, I think in optical domain, we should identify what is really the core. Of course, the DSP in transponder is one of the core. So DSP in transponders from a different vendors could be the SDKs could be very different. But for the line system, I'm not sure. Like the amplifiers, those production switch, right? So the Mux T-Mux, they don't have a core chip that's in it that we can make an energy of an energy of like Broadcom or Marvell or even Intel versus ARM, those kind of things, right? So how can we not run into the trouble of building so many different SONiC images for so many different web box vendors?
Yeah, that's a very good question. So let's move on to next page. Probably we can answer part of your question, Yahweh. Okay, what is the core, basically, right? So the router switch core is the ASIC. Now, what is the OTN's core, right? So to differentiate from these peripherals, right? We need that. So the core will decide the image, right? So
exactly.
Let's see. Yeah, let's see here. Okay, now. So this is exactly how do we differentiate what is the core and what is the peripheral. Okay, so for the peripheral, I here called is device-based equipment management. Okay, so these are generic, kind of nothing to do with the service of the box provided, right? So chassis, PSU, fan thermal, LED, SFP, right? Then this is the chassis level. And the module level, it's a supervised card. This is the router switch term and the line card, right? So this is implemented in this Python. Now, inside the module, then there's a components. Now, in the switch world, the component is BIOS, FPGA, CPLD, right? Then what you can do on these things, resources, you can, like say, admin status, restart software, firmware upgrade, and it manage also unpluggable. Okay, those are non-core. Those are device level. Device level thing. So now the right side is the core. So the core on the router and the switch is the switch ASIC. This is the biggest one. And it has also port, all these generic like an interface, forwarding, routing, ACL, QoS. So these abstract packet switch features, right? They are part of the core. Now in our OTN, the core will be, we don't have a switch. However, AMP, OPS, OCM, WS, these modules should be a core because all the interface, although the feature functionality, they are all the same from every vendor. However, the implementation, the psi, whatever psi equivalent implementation will be different. So what we will end up is here, if the core is from different vendors, then you have an image. Now, the boxes use the same core and they will share the same image. This is what the
So here you
we
have
exactly
OTN function.
follow. Yeah.
A question, one question here. Your OTN function is call. Your first bullets is the
So for example,
all
you
channel and when plan these are transponders, or it's just port channel.
oh, port channel. Yeah. These are the transponder concept.
Okay.
Yeah.
What is web plan?
Wave plan is like how do you, what is your like let's say you have C-band, right? How do you divide the C-band into multiple channels, right? The first
I
channel
see.
is 100 meg, second channel, yeah. So this is
okay.
yeah. This is the wave plan.
So one point I wanted to mention here, is it Jimmy who is giving the presentation?
Yes, Jimmy.
Jimmy, yeah.
Yeah, Jimmy. One point is like the SI or the OTI, right? That is going to be per vendor. It's a library. It is a closed library, which is given by the vendors. And whatever you there, the implementation, you can have whatever is it, that will not be available to the rest of the world. Okay, so it's going to be only for your, so if you take Infinera, if you take Ciena, if you take Alibaba, something like that, and if they have their own way of implementation for that, that will be there inside that closed one. So you will provide a library, and that will be integrated with the build system, and it will go along with the platform. Okay, so that's one point I want to mention. The second point, if you go back to your previous slide, under the platform, there will be, if you go back to the previous slide, under the switch platform, right? If you see on the build, during the build, you will have vendor specific, it's just not just Broadcom. Under Broadcom, you will have per vendor directories where you will put all your platform drivers and everything there. And when you build it in SONiC, you will basically give the hardware SKU. So hardware SKU is basically, if it is a Dell S6100 or something, so it'll basically figure out based on the hardware SKU what it is, and then it'll build, it'll pick up only those and then it'll build. So that's how it's dynamically building it.
Yeah, yes, exactly.
Right?
So
I just want to clarify some other things here, right? I mean, the flow is kind of correct, but some of the missing pieces I just wanted to enforce here, right? So that we are in line, we are in sync with each other.
Yes. So from this diagram, you can look at it like a tree, right? So SONiC support multiple platform. Each platform has many devices. Right. So that is how. Then all these devices with the same platform, they share an image. Right.
Yeah, Broadcom.
So,
yeah. But while installing, it will install only that particular vendor specific stuff.
So here, let's. Okay.
Sorry, Jamie. So when you say OTN function, right? So you're basically isolating different primitives, like an amplifier. Now, amplifier could mean various different things specific to different vendor implementations. There could be 1 amp, 2 amps. It's a very different configuration. So how do you see this kind of if you make it very device specific, like a switch ASIC or something, how do you see that addressed here? Is it because one amplifier card, line card, may have many multiple amplifier chips in it. So how do you see that getting modeled through to OTI?
Yeah.
So
yes.
So
this. Go ahead.
So who basically asked this question now?
Snigdha, yeah.
Hey, Snigdha, yeah, there's, so, hey, in that case, right, I think you will, if you have multiple within the same line card is what your question is, correct? You will have
Yeah.
different probably SKUs for those different flavors.
Absolutely.
Right? So then in that case, then that way you basically solve it. So you'll pick up only for that particular flavor of whatever thing, it'll only pick up the, so that's how it will be basically modeled.
So I mean, even transponders sometimes can have an amp device in it, correct? So then essentially what you're saying is, if you make a build for a certain SKU, it will pick up these various different components needed, correct? Okay,
that's correct.
Got it.
That's correct. Exactly. You nailed it. Yeah, that's how it for a particular SKU. So you need to come up with these SKUs, right? So so if you basically I mean, if you go to the website itself, right, SONiC build image website itself, you'll see if it takes Dell, right? I take Dell as an example because I worked with Dell earlier. So you'll have SKUs like S6000, S6100, Z9100, Z9264, like this. So these are individual SKUs for different routing switches, right? Which can, so they have different, they're basically different platforms, and they use different Broadcom chipsets itself. So one will use Tomahawk, one will use Tomahawk 2, the other one will use Trident 3, the other one might use some XYZ, something like that. Similarly, you have for Barefoot or Cavium or Marvel, right? For everything you have different, and then you will have specific SKUs for individual Broadcom chips, right? Whatever the switch name is, you will have the SKUs for that. So you basically bring everything together based on the SKU.
Okay.
Yes. So what I like to add on is the difference between the left and the right, right? So on the right side, it's a platform based. Okay. So each platform for an ASIC vendor, they will provide the ASIC driver. Optical vendor, now OTN world, we will provide the optical module driver. And so SYNCD in the switch world will be the same SYNCD as long as you use the same ASIC, okay? Doesn't matter what box, like Edge Core or Dell. If they use Broadcom, they have the same SYNCD. Now, if they use Marvell, then there will be a different SYNCD because the Marvell ASIC driver is different from Broadcom driver, right? So, but the nice thing about the SI is exactly try to solve the problem of different ASIC vendor have different implementation to configure their ASIC, right? So then the SYNCD can have the same API to call. Then the ASIC driver just plug in. So now we can emulate that behavior. So we will create an OTI API. So SYNCD can always call the same API. However, the optical vendor will provide the implementation, so-called driver, whether the user space or kernel, doesn't really matter, which will implement all these OTI, or I mean, we used to call it lie, right? So that is the mechanism here. Now on the left side is a little bit different. Left side is all these peripheral. They are nothing to do with the traffic or service the box provides. They are all generic, these hardwares, right? So these are responsible by the device vendor. Like Dell need to provide the driver for that, not Marvell, Broadcom. They don't care. They only care about SYNCD. Now the box vendor, white box vendor, they will provide all the device drivers, Python plugin or whatever. We will go to next slides to see. and to implement all these hardware, generic hardware driver, right? So they are not one-to-one, left to the right. So on the right side is less, actually is a multiple left platform will follow one ASIC. Yeah, one synchrony.
So,
right.
I have Jimmy, a quick question. I have a correction here. So you added lie and Wotai there, right? Sai. That's not the way it's going to do with what Alibaba is doing. So let's be very clear, right? So this is, you're comparing this with a switch, which is a pizza box. In a pizza box, you have a hardware device and you're basically directly talking to the ASICs and you're okay. So you use as a switch abstraction interface, and that's underlying its hardware agnostic. And you're able to basically talk to any kind of hardware, whether it's Marvel, Cavium, Barefoot, Broadcom chipsets, any kind of Broadcom chipset, you'll be able to use the same SAI API to basically program the ASIC drivers. But when it comes to us, the way the current design is for with the line, it's not going to be like this. It won't. It is not like this. This is slightly higher because this is going to be the line card now. Your line card is completely hidden from the lie or the OTA interface, which is coming from the northbound interface for us. So you will translate that to your local and interfaces, however you configure, and then you'll do it. So northbound interfaces to your line card will be the OTA or the lie interface. It's not going to be at the SAI level here. If it's at the SAI level, then it's moving towards the line card itself then. So there are two different things.
Yeah, very good point. Very good point. So this we can have a discuss when we review lie. Okay. So in my mind, we should abstract just like similar to SAI. You don't care where this amp is, right? You only know the number one.
Jimmy, one second. No. That's not the way it is, right? So okay. Let me if you take a step back and look at the design, right? So there are two ways you could design this, right? One is basically the way you have put in here using SyncD, where you are basically using a similar SAI infrastructure and then basically talking to the endpoints, right? Drivers and things like that, right? To program the optical drivers. So that's one way of doing this. If you follow this method, which is the same method as what SONiC is following in today, that means you're pushing there's no lie or anything in like what Alibaba said, you're pushing everything towards the edge of the ASIC drivers, which is basically similar to what SONiC is doing today in the networking field, right? That's not what we are doing today with the design which is being discussed. This whole thing is not here. It's one level up.
Yes, exactly.
Right? So
I agree with you. That's
clear.
why we need to talk in the second round. So line card in my mind is really the box vendors job, not the OTI job. So that I mean, at least agree with you. The current implementation proposed by Ali, the line card is actually on the SyncD side.
I mean, I won't say not. I mean, not really, because it is just an abstraction for us to talk to your proprietary architectures. I would say, right? You could have any line card underneath. You are just translating the information which is coming from the northbound interfaces to your line through your line interfaces through the radius or whatever is it, and it's basically sending it to the backend is what we are doing, right? So you don't know what is happening inside the line card, right? It's completely a black box, right? That's
but the end point is the module, right? So you go through line card, So how do you set up the module? Everybody has different. They may not have a line card, right?
You do the
they have a fixed box, so immediately they set the module. You can do that too.
I mean, I just wanted to make clear the distinction between doing it in a networking way and the current archecture, right? I mean, there are pros and cons on both, so we need to basically weigh the options. So I'm just bringing it to the forum exactly what is how it's being done today and how optical can do it in both ways, right? That's what I'm bringing to the focus.
Understand, and a very good point. Yeah, this is sort of the harder kind of tricky part, right? Once we how do we do that? Yeah.
Yeah, I mean, this needs to be discussed, yeah, for sure, yeah, but we can,
Okay.
we can.
Yeah.
Correct. Sorry to
So-
interrupt you.
Okay, no, that's a very good point. I think you. Okay, now let's just review what is a PMON currently. This is a part of the left side. Okay, so this is these two ripples. What they looks like now. You see, these are all device vendors' responsibility. For example, the current Python kind of base, the platform PMON's class structure has a chassis, right? Then chassis and the chassis, there's a EPROM, like a rebooting course. This is exactly from this document. Okay, it's not my slides. Actually, I just copied from this document. So LED, temperature, watchdog, power supply, SFP, right? So then there's also change event you need to handle. Now, on the chassis, there's this component. Also, it has a module, multiple modules. What is the module? It says it's a line card or supervised card, right? So what is inside the module or card? It's the same thing as the chassis. So a card can have an EEPROM like a temperature, LED, power supply, fan. Now, not many cards has these two things, but they put it in there anyway. Now the card has a component, and the chassis has a component, right? So the component, as I said before, in the existing SONiC world is like a BIOS, CPLD, like FPGA, all these kind of things. Now, in our world, probably we can put like optical modules, right? It will fit in there. So line card will have a component. Now, module, optical module, there's a name and a description. And then what you can do, you can upgrade software, downgrade software. You can reboot, reset. But you see, all these are nothing to do with traffic. They are all equipment management stuff. That's what it is today, right? And you guys can look at this document to do. So next thing, it is my feedback for the current implementation proposal and the proposals from Ali and the SONiC team, right? So it's very simple. So our goal is really try to be compatible with existing SONiC, right? We don't want to diverge, right? So one thing we should not do is remove the existing code, right? We should leave whatever the code it is, even if you are not using, you propose a new way of the platform management, just to leave the code there. Now, the new thing added by OTN is just these two, right? You can just add these two in the platform com repo and the SONiC PMON D in the platform daemon repo, but you don't remove that. Then, so the nice thing about leave this old existing code out is because you give the choice of optical vendors, right? Whether use Alice implementation of PMON or use existing SONiC PMON, right? So I have submitted the two PRs just to basically request to put all the original SONiC code back. Have the new code is okay, right? So then furthermore, now, even we put this code back, if we want to merge our code into the upstream community, then there will be challenges. First, the challenge is that the OTN PMON we proposed, the feature is actually, there's many duplications from the existing base classes, okay? Like a PSU, sound, fan, all these, it's there. They will ask you, I already have that. Why you wanna have base class, different set of base class again, right? So one way of doing that, I think what we can do is have this class as a subclass of official SONiC class. I don't know. It should be easy to do, right? Now, with that, you can connect your Swift server, right? Then also each vendor can just implement the vendor driver as a Swift server's implementation, right? So that is the one way we can do here. In this way, now, for example, like the other optical vendor, they build a device, right? Optical white box. Now they say, okay, I don't want to use this. Now you can still use the existing SONiC, nothing. You don't have to change anything. You just provide the Python subclass for all these fan driver, and this will be located here, actually. So then it's okay too, right? So the color in this diagram, if you look at detail, is the green one, blue is the upstream, right? Then we, as a working group, we add this orange one, right? Then in the future, anyone want to build an optical box, they need to do the blue one, either this way or that way. But we should not delete this. This is what I try to say. Yeah.
Yeah, correct. Jimmy, I think you're right. I mean, I've been proposing also the same thing for any deviations from the existing SONiC, right? That we should not be doing it like that. We should try to follow the same way design thoughts as what the SONiC is, so that it's easier for us to maintain and easier for us to even go back and push the code in GitHub to SONiC, right? So, so your thinking is also the same thing. But here, I think you're giving two options, right? There's another. So I still did not get what the Python class is here. Is it the existing one you're talking about?
What?
The green one?
The green one is, it will be, for example, the green one, for example, Ali already did this, the whole thing, right?
Correct.
So, and the SONiC, now Molex, right? Molex, if we want to build a optical box, right? So we need to do, because we have a different fan and the PSU, chassis, everything.
Correct.
From Ali's box. So we need to provide the driver. If we use OTN, yellow infrastructure. However, we also have a choice to just use existing SONiC infrastructure PMO. We don't need all these yellow one. I just need the light, this yellow one for PS. So this will be exactly same as a switch vendor to do. Yeah.
So I would say, why would we even need the other yellow one? You don't need the yellow one, right?
Yeah. So this is a debate.
No, let's not reinvent the wheel, right? It's something has already been done.
Yes.
We need to build on top of it and do extensions.
It's actually my preference. Yeah.
Right. So because if you do it like this, the maintainability is it'll become a problem, first thing. Second thing is, right, in case if you're ignoring the whole part, then anything, so you might have to add all the features and everything in your own OTN environment. So that's one part. That's the second part. And the third one is, right, if you are using the existing, and then if you're copying is also, right, then there's another problem there too, right? If you copy that and we just don't use some of the stuff also, then anything in the base, so SONiC networking has changed. If you don't use that, it won't come to you automatically. So you need to make sure that you get that. So all those headaches are there for us, right? So I think I would prefer the way of extending if it is possible, or if not, if it is a completely newer thing where we don't use any of this existing SONiC thing, then it is fine. We can just create our own new repo and then integrate it with it, right? So that will be only built for the case of OTN, right?
Yeah,
Yeah.
I also agree. Like for fans, for power supply units, those are definitely peripherals, right? So you don't want to reinvent the
That's correct.
wheel and create new drivers if there's already current suppliers drivers in it already, right? So that's that. I don't think the fans or the power supply units in OTN equipment is anything different from the routers using them. That is would be like for the peripherals. The drivers should all be in a shared library, and each different implementation of drivers just apply and pull the drivers in the library and apply it, right? So I agree. Like just the things that doesn't exist should create a new ones.
So when we implement this, because at that time we didn't see the future that we need to merge it back to the upstream. So we just remove all the functionalities we don't need in the SONiC, in the PMON or in the driver. So we keep it clean. But right now, if we want to merge it back and follow the architecture, I think option 2 is okay. But in some case, if somebody want to follow the Swift server, I think the option 1 is also it's an option, right? So I think if somebody want to use the Swift server, then they can use the option 1. But yes. So if it's the new one, I think you choose option 2. I think is fine for us.
So I don't think a SONiC community will have a rejection on if you put a subclass, right? So because I'm a new kind of a vendor, so I build a new box. So I will check in my subclass under the device or under some platform and to support my box. However, you cannot put this class as a base class, then they will will have a hard time. Yeah.
So the option 1 is just a plug in the driver, but it's
yes.
adapted
Now,
to the
so
driver.
for SONiC Ali, I mean family device, you guys just if you build a new box, you only need to do this part, right?
Yes, that's
because these two are connected.
Yeah.
Now for the other kind, they say, oh, I prefer SONiC original one. I just don't want to do this. Then it's okay too. So, or as we said, I mean, since you guys already have this working box, so I don't know. So theoretically, you can actually, if this base class is not enough for OTN, we can propose add more base class, which is okay. But you should not create a different set of the base class and move into here. Then this is not good, right? So that's all.
Yeah.
So yeah, we can, especially SONiC Ali team, you can think about this, how do we restructure the current implementation so it can make more sense to push back to the master.
Yeah, so adding on top of that, even the last CLI presentation, right? I think we were doing the same. There was a little bit of a so at least in this case we are creating new. We are ignoring the old code and we are basically creating new code for the OTN, as you say in the yellow one. But the previous one was even more bad to maintain because we're difficult to maintain, rather not bad. It's difficult to maintain because we are copying from the SONiC CLI, and then we were doing it, right? So that will have even more effect. I think there also we should just go back in a way that we use the existing one and then use the extensions, whatever is required for OTN, so that we are able to achieve the same for OTN using the existing SONiC design. Right. I think I gave the feedback last week also, last week regarding that.
Sure.
And lastly, one I think we have another 3 minutes. So last week I think we were having we had a discussion. I think we didn't finish the whole meeting fully, right? We had some of the things which were needs to be addressed, right? We didn't have time and we wanted to move to the next meeting. One was basically the VM. Is the VM, we'll be able to build the VM and everything there from the GitHub? Can I clone and build it and see?
The source code is ready, but right now I haven't tested it out. I think once I test it out, I will submit to the GitHub.
Okay.
In 1 week, yeah.
No problem. No. I just want to check because I think there was you guys were supposed to give a demo, right? I thought maybe if it is pushed, then I can probably try it out. Is what I thought in a VM. So I didn't see that. That's the reason I wanted to ask that question. Yeah, thanks for
Yeah.
updating.
Yeah, you need build the image rip. So after that pushed, right?
Yeah.
Okay, now another detail I want to add is hopefully this change, right? Instead of a base class, whatever we have already in the OTN PMON can be a subclass of the Python. This will be a change. Now this PMON you even don't have to change. It's a standalone. You prefer have one daemon instead of a multiple daemon as SONiC, right? And the daemon part is actually all the PMON daemons is configurable under device. Okay, so each device you actually can control, say, okay, now these daemons, what I want to run, what I don't want to run. So it's perfectly okay. Once you add this check-in, if you still want to use your existing implementation just under Alice device, you start this PMON and you skip all the existing SONiC daemon. Then they will not stop. So this very good infrastructure there to have the customization for each box, basically. The mechanism is there already. Yeah. So either we have build time flexibility and also runtime flexibility there.
Yeah, and this PMON is basically a container, right?
Yes, correct.
Yeah, it's a container running, so it's just a container. So we should. Be able to
This PMON is a container, then these all they are processors. Yeah.
Correct. That's what I wanted to say. It's a container running, so it should be inside the container. Yeah.
So what I mean is like as long after you guys make this subclass of this, then should not have too much change. So you can still launch the PMON, right? Instead of multiple like existing daemon, if you prefer that, yeah. Because it's a well structured. Okay, that's all I have actually.
Very good. Any other questions for Jimmy? I think that we just use up of our time. So I think that's all for today.
Yeah, thank you, Jimmy. Thank you, everyone.
Okay, thank you.
Bye. Thank you. Bye-bye.
Bye-bye.
Bye.